Hi everyone, hope you're doing well today. This is one of our last parts of the year, so hopefully we have 2 lessons left and then we're just reviewing and having a test on units 8 and 9. So first, your homework was to do the linear regression review, and so I just want you to check the answers, make sure you have a complete understanding of linear regression from unit 2, because we're going to be using that a lot in our last little unit here. So our lesson today is called Does Seat Location Matter? It's our last packet. It's very short. Now this one, we want to know, do students who sit in the front rows do better than students who sit farther away? And so what you should be able to do is answer questions 1 through 6, I believe, on the front, all on your own. And then you'll pause there to check the answers, and then we will move on. So the review from yesterday should help with this. We want to use technology to make the scatter plot, so you can use Staplet or your calculator in number 4. And then same with number 5, you want to find the least squares regression line, which we put some notes on in your review last class after the test or quiz from unit 8. So hopefully you got some of that. And then we want you to interpret the slope. So pause here to complete that, and then when you're ready, you can unpause to check the answers, and we'll move on to the next part. All right. So number 1 was an experiment because we assigned the row to the students, and so that was a treatment being imposed, which allows us to show causation. We have 2 quantitative variables, which is when we would use a scatter plot, and don't forget explanatory and response are how we identify the x and the y for the scatter plot. And then the least squares regression line, we just want to make sure we have this from, I got mine from Staplet, but you could use your calculator too. If you use the calculator, you'll put the row into L1. Oops. The score into L2. And then to get the scatter plot or the LSRL, you do stat calc 8 gets you that. One thing I want to make sure we do is define the variables. So you want to write off to the side x equals row, y hat equals predicted score. Don't forget that it's the predicted score, not the actual score here. And we can see a negative association in the scatter plot. It's pretty weak, but there still is a negative association, and so we want to explore that a little further. That's why we have a negative slope. And then for your interpretation, hopefully you practiced that yesterday or last class, so you're able to get that. Don't forget about the flashcards that we have from Unit 2. I'll link them into Canvas, so you have those as well for this last unit. All right, so all of that was, let's see, I had 2 number 4s. All of that was just a quick review, but now what we want to do is tie this into inference, which we've spent all spring doing, starting with sampling distributions. And so what we want to do is think about, okay, well, does the negative slope that we found provide convincing evidence that sitting closer causes higher achievement? Or is it plausible that this association is purely by chance because of random assignment? So we randomly assigned students where to sit. Did that impact their score, or were they just going to have random scores either way? So the way that we'll answer this question is I want you guys to take all of the scores that you see here and put them on index cards. There's 30 scores. So write 1 score per index card. And what you're going to do with those is shuffle them up so that we can assume seat location has no effect on exam score. Now let's pause here. And this should be pretty familiar phrasing. Assume that there's no relationship or no difference, no effect. And so that's going to be our null hypothesis when we do inference with this. Today we're just setting everything up, and we'll work on that next class, but just to get you thinking about it. And remember, we do inference by assuming the null is true. And so the way we make that true in this case is instead of assigning the seats and having students take tests, we just assign random scores to random rows so that we can make this true, this red underlined phrase true. And so you're going to do that 3 times. Let's say I take my scores. I'll do a quick example. So I wrote all the scores down, shuffled them up, and then, let's see. So I'm going to pull out my very first score, and let's say it says 83. And then I'll pull out another score, and it says 72. And I'll keep doing this. I'll just fill in this 30 scores across these 30 blanks, and then I'll find the slope. Now, one thing I want you to remember is that 83, this would be an ordered pair of 1, 83. So if you used Stapled before, remember all of the explanatory variables are still the same: 1, 1, 1, 1, 6 1s, then 6 2s, then 6 3s, and all the responses need to go in this order. This is 1, 72. And then you'll just use Staplet or your calculator to find the slope. I would use my Staplet because you can just, or either one will be just as easy. Find a slope, repeat this process 2 more times. And then what you're going to do with that is, if we're at school here, we'll put a dot plot on the board. We'll have all of our slopes on the x-axis, and then you'll put a dot for each of your 3 slopes, and then the whole class will do that together, so that we'll create what you should be used to as a sampling distribution of all the different slopes possible from randomizing the scores with the rows. All right, so I'm going to have you guys pause here so that you can complete this experiment on your own, and then we will come back together once you have all the data and analyze it. Okay, so let's scroll down here, and even though this is a lot more dots, so I ended up just doing this myself, 1,000 times. I had all the time in the world to get this done, so I just did this myself 1,000 times, and this is the distribution that I got. And so we have a couple of notes to take about it. Of course, I want to start off with circling one of the dots and saying, what does this dot represent? So remember, each of your dots that you guys found was the slope of the sample LSRL. But remember, when assuming no relationship. And so what we would call, remember, when each dot is its own sample, that's what we call a sampling distribution of, and then whatever we write after of is what this is, what each dot is, which is the sample slope, lowercase b. And so I'm going to write sample slope there. A couple things to notice about the sampling distribution of the sample slope is this should look, approximately normal to you guys. Let's see. And so I'm going to write capital N. And then the center, remember, we assumed no relationship. And so that should be the center, no linear association. For the spread, we have something called the standard error of the slope that we'll talk about in a little bit. And so this is, in general, the sampling distribution. Now, what we were asking was, is there evidence that seat location affects your exam score? And so remember, we want to look at our result, which was, our result was negative 1.517. So here's about negative 1.517, and I already did this. I counted up all these dots because remember, I have all the time in the world. And so I want to see, what proportion of the dots are at negative 1.517 or more extreme than negative 1.517, so lower. And so I got about 156 out of the 1,000 dots, which is 0.156. Now remember, when you look at a sampling distribution and you calculate a proportion like this or a probability like this, that's what we call the p-value. And 0.156 is a pretty large p-value. It's bigger than any alpha we would use. And so we do not have convincing evidence that the seat location affects your score. And sometimes this is backed up by the scatter plot, remember? It doesn't look very strong at all, but depending on the sample size and all of that, we still want to be able to use inference to determine if there's officially a cause and effect relationship here. But I would say about no. And let's just write down one more thing, because we have remember our no effect on exam score null hypothesis. And we'll talk about this a little later, but I want to emphasize that means that our population slope equals 0, and we have a new symbol, population slope. This fits right in line with how we typically use Greek letters for population values. This is the Greek letter beta. It is not the same beta as a type 2 error, but it is the letter beta because we use lowercase b for sample slope and then beta, the Greek letter, for the population slope. And our null would be no relationship, no linear relationship, so we would always set that equal to 0, just like we've done in many other significance tests. And then our alternative would be whatever we're investigating. In this case, does the negative slope provide evidence that sitting closer causes higher achievement? So my alternative would be that the slope would be negative. But we did not have convincing evidence because in our sampling distribution simulation, we got a p-value of 0.156, and that's bigger than any alpha. So our notes here are just going to be pretty quick, just reminders of what a sampling distribution is and some symbols. So basically, just the important ideas are that we have a population, and that has, this is the population LSRL. So the mu of y equals alpha plus beta x. Remember, we use Greek letters to represent population values. And then in the sample version of that is what we're used to getting, y hat equals a plus bx. So for our table here, right here, we have statistic and parameter. And remember, statistic is what is from a sample, and parameter is from a population. So these are all Greek letters, and these are all regular letters. We should know A, B, S, and then now we have this new SE sub B, the standard error of the slope. And then the parameters are alpha, beta, sigma, which we know is standard deviation for a population, and then standard deviation for the slope. The sampling distribution of the slope is normally distributed with mean at 0. Standard deviation is the standard error of the slope. And so if we want to do a significance test, remember, we just find our sample slope. In this case, it was about here. And then we shade towards the tails. And we'll do the same thing. If we had a not equal to sign, we might have shaded both. Less than, just the left. Greater than, just the right. We've done this plenty of times. So it's the same idea. Now, I want you to pause here so you can copy the rest of this down since I've been blabbing away. But when you unpause, I want to just go over this check your understanding computer output with you right before you do it so I can explain some of the symbols in case you forgot. So when you unpause, we'll talk about the the check your understanding before you can work on that. Okay, so for this check your understanding, I just wanted to debrief really quickly before you get started on the computer output. So don't forget that in the computer output, the constant is your sample y-intercept, and then whatever's next to the x variable is your slope. This is your x, and so we know x is the drop height. And then we never are going to use these top three, but now that we've learned SE coefficient, it's SE, and then it's in the slope row. So this value is your SE of the slope, 0.00218. And then next class, we'll talk about the T and the P, but hopefully those are familiar to you, a T, test statistic, P, P-value. Remember, we never use the R-squared adjusted, so just cross that off. You don't even need it for this problem. Then this is your standard deviation of the residuals. And so that's your estimate for sigma, and then that's really it. This B sub 0 is old way, now we call it A. So those are just some things. And then beta sub 1, that's just beta now. So you can use your notes now to do the rest of this, but I just wanted to kind of briefly go over what all this means. And then you can use your interpretation flashcards that are linked in Canvas to help you with this. We do have the one for this SEB in there. We ignored it when we looked at it the first time we saw these in Unit 2, but now we need it. So feel free to give it a shot and unpause when you're ready. All right, here you go. So I use the flashcards and just some general knowledge to do it. Don't forget that it needs to be in context for everything. Even though the y-intercept makes no sense in context, we still want to do it. Don't forget about words like predicted and on average. And then all standard deviations are typical variation from the mean. So I'm just going to remind you of that. Standard deviation in general is typical variation from the mean. And so in this case, mean would be whatever we're looking at. Slope, we'll just put parameter. All right, so hopefully you did fine with that. If not, just make sure you keep studying those flashcards. You will need to know those for your exam. And I hope you guys have a great day, and I'll see you next time.